Good afternoon. My name is Arun Chabra and I'm with 8tree, and we appreciate the opportunity to share some of the interesting developments from our side. We are a tech startup and our focus is on making application-specific 3D optical scanning equipment. And we have patent-pending visualization technologies that allow us to, as benchmark in the industry today, allow us to significantly boost workflow efficiency, while also significantly enhancing the user experience, abstracting complexity, and really making the dimensional measurement tool a workplace tool, not an engineering platform. So we'll start off with a quick 2-minute video that showcases basically one of our 3 products, and then we'll do a quick demo and wrap it up. So all of our products rely on the same common foundation of structured light illumination, which is an optical measurement technique that, click on this. Yeah, it's an optical measurement technique that basically allows, based on triangulation techniques, allows measurement of surfaces. Now, what you saw was the fastener flushness product. The same underlying, this is the fastener panel, a test panel from the aerospace manufacturers that has a series of rivets, fasteners. Some are high, some are low. Currently the state of the art is they measure one at a time with a dial gauge, and it's a very subjective process. I've replaced it at a random location, and we'll run it again. And you see it's once again, it's color-coded, numerically identified, all the fasteners according to the defined tolerances. The power of this and the other 2 quick demos you'll see is really that we're taking the decision-making capability outside of the lab and into the hands of the operator. So all the scientific data, the millions of points of 3D data that accompanies every scan is still available for review and analysis. But we abstract all the complexity, and the operator, the person on the floor tasked with doing the job to maintain efficiency on the line, can now simply make a go, no-go decision, a yes or no decision, and proceed with the job. The other test panel we have over here is a mock-up of a surface that has dents and protrusions on it. And you see over here it starts to indicate in real time, and we can reduce the brightness a little bit. It basically gives a texture map of all the high points and low points and on a pixel by pixel basis allows you to see and monitor the formation of those problems. And so the final aspect is, the final third product is really, again, if you have surfaces where gap and step or gap and flush are issues, and it's an issue in a lot of manufacturing environments, automotive, aerospace, where you need to, in real time, detect that gap and that step. Typically you use a manual dial gauge and you check point by point, and it's a very, all of these, the status quo is a very subjective process. I hold a gauge and do it, and you hold a gauge and do the same point, and we'll get two different results. Quite honestly, if I hold the gauge and do the same measurement at the same point 3 times, I'll probably get 2 different results. It's a subjective process, and what we do is we remove the user intervention, and with this patent-pending visualization augmented reality technique, we present the information right on the surface, the measuring surface. And so you see in the field of view, we're taking about a dozen points that we're defining the gap and the flush, we're putting it through decision making. So when you see this, the question you might ask is, well, why is this relevant? Could we switch over to the slides, please? So why is this relevant to structured health monitoring? Well, we make high performance, intuitive, 3D optical scanning equipment, and that's a non-destructive test equipment. And it delivers very detailed surface characteristics. And what we've seen based on the problems that we're targeting, the applications that we're targeting, these surface characteristics are a direct indicator of structural integrity and structural health. And that's what our customers in the aerospace, automotive, oil and gas pipeline, satellite communication fields, to name a few, are finding as well. Fundamentally, it's the question, again, that you might ask is, well, what's special about this optical scanner approach versus the dozens that exist out there? And it's, again, goes back to the status quo comparison that I'm talking about. Tactile methods are constant contact, every point you touch, every point you sometimes touch multiple times. General purpose optical scanners require a lot of user software scripting. For every scan, a significant amount of analysis in the lab before you can take action. What we're basically delivering with the patent-pending augmented reality and gesture-controlled techniques, we're taking it away from a world of constant contact to dozens of menu configurations on a general-purpose scanner, down to one button. So you saw me press one button for every scan that we just did. And with the gesture-controlled techniques that we're now implementing, you're taking it to a step forward from one button to no buttons. And that's basically what we're bringing to the table. So I don't know if we have any time remaining. I'm happy to take questions. Otherwise, you're welcome to come and see our booth in the Grove. Thank you.